Dear students, in the last video I explained about type of intervals, interpolations and everything. And last class I told you we have three types of interpolations. The first one is forward and backward interpolation. This is applicable only for equal intervals. And the second one is divided difference interpolation. This is applicable only for unequal intervals. And last class I gave you the formula of Lagrange's interpolation. This is applicable for both equal interval and unequal intervals. Okay, and this is the formula of Lagrange's interpolation, and this is our Lagrange's inverse interpolation formula. Now we are going to discuss some simple problems on Lagrange's interpolation formula. Now observe here. Use Lagrange's interpolation formula to find f of 1.4. Means we know that we are going to represent functions always in the form of y is equal to f of x. Find f of 1.4 is nothing but find y when x is equal to 1.4. Okay, so this is the given data. Here he given some values of x 0, 2, 3, 4, and corresponding values of x we have the values of y also -4, 2, 14 and 158. Now consider the given data first and denote the values x0, x1, x2, x3, similarly y0, y1, y2, y3 and all. After considering the data, first identify what is the requirement. Find f of 1.4 means we are finding the value of y when x is equal to 1.4. So now consider Lagrange's interpolation formula. We are finding y here, so we need to use Lagrange's interpolation formula. Consider that formula, x minus x1 and everything. Substitute the corresponding values. We know x1, x2, x3, x0, y0, y1, y2, y3, everything that is in the given data. X is nothing but we are finding y at x is equal to 1.4. So where you have a x replaced by 1.4, we will get the value of y at x is equal to 1.4. A simple working procedure. Similar to this. So observe here. Use Lagrange's interpolation formula to find y when x is equal to 10. Same thing, we are finding y when x is equal to 10. So we need to use Lagrange's interpolation formula. As usual, first consider the given data, denote its values, so x0, x1, x2, x3 and y0, y1, y2, y3, everything. Consider the formula, Lagrange's interpolation formula. So x is nothing but 10 because at this point we are finding the value of y. So x is 10, x1 is given 6, x2 is also given, x3 is also given, x0 is nothing but the initial value of x, y0 means the initial value of y. Similarly substitute in the second term, third term and the fourth term. We will get the value of y when x is equal to 10, that is 14.67. Here the procedure is just consider the formula and substitute the value. That's it. Now in the next problem, apply Lagrange's inverse interpolation formula to find x when y is equal to 6. Observe here, we need to find the value of x, not y. So when you are finding the value of y, we are using Lagrange's interpolation. But when you are finding the value of x, we are using Lagrange's inverse interpolation formula. So in this problem, we need to find x when y is equal to 6. So consider the Lagrange's inverse interpolation formula. And here, we don't have x3 and y3 value. So in each term, y minus y1, y minus y2, no need of y minus y3 because y3 value is not given. Okay, so this is the formula for given data. So as usual, we are finding the value of y when x when y is equal to 6. So y is 6, this y is 6, and we given the y0, y1, y2 everything. Similarly x0, x1, x2, substitute in the formula, you will get the value of x when y is equal to 6. So observe, there is no difference between the Lagrange's interpolation formula and Lagrange's inverse interpolation formula. Now one more problem. Apply Lagrange's inverse interpolation formula. Sometimes we won't mention which method we need to use. Okay, in that case we need to identify by using the statement. So for example, observe here, if the problem is find a root of an equation f of x is equal to 0, given that we given some values here. We know that f of x is equal to y. So within the bracket represents x value. Right hand side represents y value. So here the data is x0 is 30, x1 is 34, x2 is 38, x3 is 42. The corresponding values of y. y0 is minus 30, y1 is minus 13, y2 is 3 and y3 is 18. And we are finding, apply Lagrange's inverse interpolation formula to find the root of an equation f of x is equal to 0. So compare this expression with a given. Which one is given here? Y is equal to 0 is given. At what point of x? We don't know. So we are finding what is x when y is equal to 0. So when you are finding y is equal to 0. So when you are finding the value of x, we need to use Lagrange's inverse interpolation formula. So consider Lagrange's inverse interpolation formula. I told you, if this statement is not given, then you need to identify which one is the suitable one. So compare these two problems, the previous one and this one. Here in the previous problem we gave only 3 values of x and y, x0, x1, x2. But here x0, x1, x2, x3, 4 values. So observe the problem. In this problem, the formula we are using y minus y1, y minus y2 into y minus y3, because y3 is given here. Similarly, in the denominator, replace y by y0, y0 minus y1, y0 minus y2, y0 minus y3 plus x into x0. So first term, second term, third term. In the previous problem, we have only 3 values of x and y, so only 3 terms in the formula. But here, we have a 4 values of x and y, so we must have a 4 values, 4 terms. First term, second term, third term, and this is my fourth term. So now as usual, replace all the data in the formula. You will get the value of x when y is equal to 0. So the value of x is 37.23 when y is equal to 0. So I will stop here because for the next problem we need some more time. So we'll take that in the next video. Thank you.